This is a video walkthrough of solving for an unknown number 14. We have an Olympic event here, single luge. These lugers are going down on a small sled and they go really fast around sharp turns. We want to get the normal force and the frictional force on the luge. And here are two equations. There's the first one, there's the second one. We have two unknowns, F sub n, the perpendicular force, the normal force, and the frictional force. We have to solve for both of them. Let's start with the top equation and solve it for Fn. We want to get Fn equals something using only the top equation. Then we're going to plug that expression for Fn into the bottom equation, so the bottom equation will only have the frictional force in it, one equation and one unknown. So with the top equation, we can start by adding 1,000 newtons to both sides. So we have 0 plus 1,000 newtons on the right-hand side, and minus 1,000 newtons plus 1,000 newtons as one of the terms on the left-hand side, which leaves this. Now we want to get the frictional force over to the other side, so we add frictional force sine 60 to both sides, and we get this. The left-hand side is only now Fn sine 30. Now we divide both sides by sine 30, and we get Fn. And let's plug in the trig functions here and do the division, just to make it look nicer, less complicated anyway. So the normal force is 2,000 newtons plus 1.732 times the frictional force. And we're done with equation 1. Now we're going to substitute this expression, 2,000 newtons plus 1.732 Fr, into the bottom equation. And here's the second given equation. This was given. We can substitute in for Fn. There's our expression, 2,000 newtons plus 1.732 frictional force. That's Fn, and that gets multiplied by cosine 30. So now we have one equation and one unknown, and we got to crank out the algebra. Let's first plug in for these values, cosine 30 and cosine 60. Now we're going to distribute the 0.866 in those square brackets. And we get 1732 newtons plus 1.5 frictional force plus a half frictional force is 5,041 newtons. Almost there. Subtracting 1732 newtons from each side, and then we can combine these easily. It's 1.5 plus a half, that's 2 frictional forces. Then we divide by 2 to get the frictional force. About 1650 newtons. But we're not done, because we need to get the normal force. We have to get both forces. But we derived an equation for Fn using the top equation. And there it is. 2,000 newtons plus 1.732 Fr. We know what Fr is. We just calculated it. About 1654 newtons, so we just plug that in and do the math. About 4860 newtons, which is close to 5 Gs. Quite an acceleration.